So let's begin then. Um, During last week, I was observing your assignments, how you were going about them. So in light of that, I've prepared a session mostly about trying to guide you through some of the mistakes I witnessed. Okay, so to make sure that you guys are converging to a good solution. Okay, I will present arguments later on. So I've prepared a small demo, okay, to illustrate a couple of points. And I wish to revisit what I mean by state management, what are our main concerns while managing state, okay? I also prepared a video for the course Prodigy I am creating, but those videos are in Portuguese, so yeah. Um, for the most of you, you can use them, but for the Erasmus students, you cannot, but that's okay, right? Um, so there are mostly two playlists. One playlist where I have the videos and unplugged, right? I'm just speaking my mind out to using some slides to my computer while recording. I make some cuts on the resulting video, and that's it. But then there's another playlist with the videos recorded in a studio, okay, an FCCN studio. So I think those are a little better. Moving forward, maybe in January, I will also have some exercises and small demos and small questions. Maybe they can come out in time so you guys can use them to prepare yourselves to this course exam, okay? So let's begin. I will open the project here. I also have a couple of slides I've used in those videos. This is why I'm speaking of them, telling you about this. I will use these these images from the slides, but I want to focus for now on the example, okay? Oops, this is on the wrong screen. Not just now. And here it is. Okay. Well, so first and foremost, let's run this, okay? The demo and show you guys how the demo is working, like this. If we have the time, then I will show you how to go towards the final architecture, which is using flows and having a full reactive architecture, okay? But later on. So here we have the login demo, okay? This is the button. We also have the jokes demo. I'm not sure where we were left where we stayed in the last lecture, but we will look into it later on. For now, let's focus on state management. And this is the login demo, okay? So I press here and we have a login screen, basic login screen. What I want to highlight here is that while the user, there are many times some confusion between what is presentation state and what is application state, okay? And my goal is to clarify the differences. Why is that? Because presentation state is kept in Compose, application state is not. It's outside of the UI, okay? This is why this is important. So for me, application state is everything else apart from presentation state. And this is a good example because it makes it simple to identify which kind of state we are talking about. For example, while I'm editing here, this is clearly presentation state. You agree, right? Why is that? Well, because this is about interacting with the user. I am writing the user credentials in the UI. And this is clearly presentation state, right? So here I am writing. He insists on capitalizing it. I don't want it. But what I'm writing there is my email. And now I'm going to write some password. Okay. And as you have noticed, what happened is that since I have some content on the password field, the button became enabled, right? Already transitioned to the enabled state. Normal, right? But we are still talking about presentation state. When is this state promoted to application state? At this moment, when I press entrar. Okay? Oh, sorry, this is in Portuguese. Why is that? Well, I will fix it later. Okay? Login. It takes some time. I'm simulating the login. And once login succeeds, I am redirected to the main screen. Okay? When has the presentation state been promoted to application state? At the moment the user pressed login. That is the moment where, why is that? Why is it promoted? Well, because I need to use that data to actually perform the login procedure. Yeah, go ahead. Okay, the question is, where will we store the token we receive from the web API, right? That's the question. Well, there are several ways to go about this, but in my mind, the ideal place is to store it in a user repository. We store in the user repository the information regarding the user, namely the token, the authentication token to be used in all requests. There's an authority, a globally viewed authority, which regulates access to the user data, namely the token to be used in all interactions, okay? So in the same way I've been talking to you guys that there are pieces whose role is to communicate with the backend API, the services, we also may have local storage, temporary or persistent, regardless, which act as authority for pieces of data. In this case, the data associated to that user, namely its token, his token, right? You got it? Yeah? Bring it on then. Ask again. So let me just say, I will try to draw something. Give me a moment. So the general idea is this. We have been focusing on the user interface and in organizing the user interface. We are focusing on that because we are at the client, and that's the greater part of our application, right? At the client. But regardless, we still have other elements in our solution which play important roles. Namely, how do we go about storing data, and how do we go about talking to other devices, namely through a web API, right? So we need other pieces, other elements of the solution to go about this, okay? So, and what I have been saying to you guys is that there's a frontier between the UI and the remaining of the system. And that frontier is clearly the view model. That's clear, right? The view model is therefore the frontier between the code of the user interface and the remaining of the system. Okay? But, let me... So, I would like you guys to please ask questions, okay? Because as I'm not obsessed in continuing forward, okay? I merely wanted to fast forward to the moment where we build the skeleton of a reactive application. Why is that? Because that's the general form of the end solution, okay? And if we go there, if we reach that state fast, then we can start building our applications without fear of having to change everything once we have all the elements at our disposal, okay? So this is why I am moving fast towards that, but I'm not obsessed about reaching that state immediately, okay? So what's more important is that you guys understand this, okay? Again, I have been talking to some of you, and I've been seeing some usages of framework elements that you guys have seen elsewhere, okay? But remember, even LLMs are trained with data, and there are two. When it's common knowledge, they perform very well, right? Why is that? Well, because it's common knowledge, and they have many examples of that training in their training set. But there are two problems usually, which is lack of training data. You will encounter this in concurrent programming. For you guys that already have attended to concurrent programming, you surely remember this, that some solutions will be plainly wrong because there's not enough training data on the training set used for that LLM. And another is poor training data, okay, poor solutions. And there's a lot of bad code out there, okay? But I will talk a little more of this today, okay? So just let me to quick time, new movie recording. So here we are. So you asked me, Bernard, you asked me, please rephrase again the question. You may do it in Portuguese. I will translate. Don't worry. Mm-hmm. Mm-hmm. We're going to need it, yeah. Well, what do I do with it? Okay? O que é que eu faço com isso? Yeah. Okay. So I was saying, so the question is, okay, I understand we have a moment where we interact with the web API, we get back a user token, right? An authentication token that I will need to use in every request henceforth, okay? From that moment on. How do I do this? Where do I store that token? There are several approaches to this, but the idea is this. Well, we have our UI built around screens. For me, a screen is a logical unit. It's what the user sees and occupies the full screen of the device, okay? This is, for me, a screen. I've been pushing towards this approach. For each screen, we have an activity, right? A view model, and a state machine with several views according to the current state of that state machine. And this is the triple that we have been using to specify each screen, right? These are elements of the UI. This is all UI related, including the view model, yeah. 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 This is the general form of it. But as you are observing, yes, some screens don't actually need a view model. When do we really need a view model? When our state machine transitions can be triggered by asynchronous operations. And an asynchronous operation is every time I need to have input-output. I must have an asynchronous operation. Therefore, when we have to implement a state machine for that screen whose transitions can be triggered through asynchronous operations, then we need a view model. It's not about preference, it's about correctness. We have to have it. Or something similar to it. Okay? But there's no point in traveling back in time and use something different than the view model. The view model is available, let's use them. Okay? Another point I've seen, some of you guys are using navigation host. Okay? For you guys that have using navigation host, remember, you need to have a nav host. It's the navigation library for Compose. Okay? For you guys that are using it, you need to have view model store owner, one view model store owner for each navigation route entry, okay? Some of you guys are using it, but most of you are not. But it's okay, you can use it. Just remember, it's not acceptable to have a single view model. Why I'm saying this? Because if you are using NavHost, probably you only have one activity. But it's not acceptable to have a single view model in all of the application, okay? In that case, you need to have several view models. And each view model will be pertained to one screen. And a screen, is, in that reality, is materialized as a route, okay? A route destination. And that should have its own view model. That's what I'm saying. But I was wrong. This why? Because all of this is about the UI. But what about the remaining of the system? This is structured according to the user experience. The remaining of the system is structured according to the domain and the remaining elements of the solution. If we have an API, then probably we will have several services. Oops, sorry guys. We'll have several services. If we have local storage or remote storage, probably we will have several repositories. Okay? These elements are the remaining elements of the solution and are determined by our domain and the specificities of the rest of the system. Okay? Meaning, if I have the need to locally store user data, then probably it's a good idea to have here the user credentials or user repo, which stores, for example, the authentication token. This element, this piece, is the authority for that information. It answers whether the user is logged in and whether it has or not an authentication token. And I can store there more information if I want. For example, the username. Okay? And who knows about this stereotype, this piece? Everybody. In the same way that everybody knows about the existence of a joke service, my joke service, because my domain was the jokes, right? The difference is that the service provides a service of communicating. The repo provides the service of accessing storage. That's it. But they are both globally accessible. Yeah? Is it acceptable for services to have dependencies of repos? Yeah. Okay. Yeah. Go ahead. Ask. Okay. I understood. Yeah. So, this is another important point. Okay. You guys are designing a web API, okay, in another course. You guys are designing a solution that provides access to the system functionalities through a web API. And that is the backend, okay? In that context, what do we have? What is the presentation layer of that element of the solution? What is the presentation layer? It's not a UI, it's an API. But is presentation. Your controllers from Spring MVC. You have input models in the form of input parameters of the requests, right? You have output models in the form of JSON mostly, for sure, I think, right? And those are elements of the presentation layer, PL. The controllers, the input model, the output model, and whatnot, okay? And of course, the mappings between routes, URLs, and the corresponding handlers, methods of the controllers. Yeah? This is it, right? So, those elements are all in this layer, presentation layer, of your backend solution. Usually, in that context, we have two more stereotypes. The first stereotype are the services, sorry, but are So let me just regulate expectations here. It's my mother. And, okay. So I was saying, um, this means that now you have here the remaining of the system. Similar to us in our client, right? We have the presentation layer, in this case, a user interface layer, and the remaining of the system. And the same here. Here are the controllers and whatnot. What do we have in the two remaining layers? Well, the services and the repositories, or another data access pattern. Okay, there are several data access patterns. Probably you are using some kind of transaction script. I'm not sure, but probably you are using some kind of approach to that, because it's the simplest one, actually. And as you know, we all love simplicity, because simplicity is not easy. Yeah. The model view controller pattern here, what is the model? Okay, so the model and the view, sorry, the controller and the view are both here. And you may think of the controller of being as being in the border between these two realities. Okay, and this means what? This means that what about the rest? What about remaining elements of the solution? So there are services, repos, repositories, or whatever data access patterns you have. Okay, it's not. Oops, it's not that important. Repository, or whatever. Okay. Usually, the dependencies here go this way, meaning that it's common to have a service depending on the repository or whatever data access pattern you are using. Okay? And yeah, you are right. This, with your expectation, this is what's more common. On the client, though, sometimes this is reversed, the dependency. And why is that? If you guys look into Android's official documentation, you will find this. You'll find this approach to structuring the application. Okay, so don't be surprised by it. The point is that the overall architecture of the solution depends mostly of its purpose, and the goals on the client are different than the goals on the server, and therefore we are in a different context, and this means that actually the role of each of the solution's elements may change or may have other dynamics between them, and it's okay. So we shouldn't believe in absolute truth or global truths in our line of work, okay? Because you for sure know already the joke, okay? The most common answer to a question in our line of work is it depends, right? So keep that in mind. But here I am not putting much emphasis on this because it's not actually really important, the difference between one or the other. But I understand that you are currently engaging in two different views of this, and it may be confusing. But don't be, because it's common to, at the client, have one dynamic, one organization, and on the server, a different one. It's normal, okay? Because the solution purposes are different, okay? So, going back to this, it's common at the client to have this. Instead of having services depending on repos, we have repos depending on services. Why? Imagine this. Imagine that, what is a repository? A repository is a representative of the data. It is responsible to obtaining it and accessing it. For all purposes, the repo represents all the data as if it were in memory. When I try to access the data, the repo, if it doesn't have it in memory, it will fetch it, right? Either from storage or from another web API, remote server. And this is why if the repo stands as the representative of the data, then it has a local storage, but that local storage is by definition partial, meaning I cannot have all the data of the system in the client. I only have a part of it, for obvious reasons, right? Because the system is multi-user and with huge amounts of data potentially, right? I cannot bring that every data, all of the data to the client. So this is why we have here a partial data, a partial copy of the system's data. But what about the rest? If I need it, how do I get it? Well, the repo may use the service. A service fetches it from the cloud, okay? And this is a common pattern at the client, okay? To have the repo depend of the service which it will use to fetch the actual data if it's not present on the local repo. Okay, you get the idea? So here I'm not having much emphasis on whether the repo depends of the service or the service depends of the repo, because it depends actually of our purpose. In the user information, going back to here, in the user login, yeah. So I have a couple of concerns here. First is, how do I communicate with the web API to actually obtain the authentication token? Second, I need to store it locally. Do I really need two elements of the solution? Maybe I can go about it having everything in one place. The login service stores the authentication token. And everybody that wants to, and it's for all purposes both a service and a repo. It's a hybrid, right? Is that a problem? No, actually it isn't. Why is that? Because it's small in size. It only has a couple of operations and a token, right? But if that would to grow, then we would have to cut somewhere. And then it would have that separation. It will have like this. It helped. Okay? So I'm not polarizing you guys on this, because actually if you use these two, services and repos, then probably you will eventually get to a good solution, keeping each piece in its own role. In some cases, joining them may make sense, and that's okay. Okay, so the point is, if the piece is growing too large, we need to break it down somewhere. That is the point. Okay, that is the main concern. Another thing to keep in mind is that it's not usual for services to depend on services and repos to depend on repos. Do you understand what I'm saying? Dependencies between repos are not natural. Dependencies between services are not natural either. Meaning that if you are designing towards this approach of having dependencies between repos, then something is wrong. You haven't break it down in the correct place. Okay, that's the general idea. So yeah, that's it. Yeah, okay. So let's continue then. I actually have here. Okay. Okay. Yeah, it's going out. Okay. Cool. So I have here the demo. You remember how it behaves? We are editing, then we do login or entrar. I will change it later. Login, and it navigates back to here if everything goes well. If anything doesn't go well, and I have injected a failure, which is if I use another email different than my own. Okay, Paul is LPT. This is wrong. Regardless of the password, this will fail. Okay. This is a demonstration of why I like to use fakes while in dev time. Why is that? Because I can easily inject errors. Okay, if we look at it, we will see exactly that. Let's look at the login service. Okay, and the login service is simply a suspend login function that receives user credentials and returns the authentication token, or throws invalid credentials exception. Again, this is a choice. I am opting for producing errors based on exceptions. I'm not defending this approach, okay? There are others more elegant, such as the either you have already seen in other places, but I'm being consistent, okay? I'm not defending exceptions as the means to report errors, but it's what I'm using here. And the fake login service behaves as like this. If the credentials are not my own, then it fails. Yeah? Otherwise, it produces the fake authentication token. Cool? Simple as this. So let's look at the login form and how I have structured it. Okay? For the best part of this course, I've been stating that we should design UIs as state machines. Okay? I have been insisting on this idea. Like everything else, we are engineers, and therefore we must know when to break rules. Okay? We should sometimes break our rules. Otherwise, it would be extremely complicated in some cases. But let me explain to you why. I have here the login form. And the login form has a couple of states. Let me get this. Those states are these. Okay? Don't mind the title in Portuguese. I'm focusing on the image, okay, these images. So these are the different states. The user is editing, and the data is not yet valid. The user is editing, but the data is now potentially valid. Okay, for example, there's something inside the password field, and the user is no longer editing. He submitted the data, and something went wrong. So there are several states here, okay? But instead of having for each state a different state on the state machine, I opted to make it all of this, put it all in the same composable, okay? Like this. Yeah, it's okay. Okay? So this is my login form with everything, but with conditional emission to the composition. And this is the other one, the outermost login form, which is the one that has the presentation state. Okay? So if we look here, you see the different compositions according to the state. As you can see, this composition and this are the same, with a minor difference, which are the modifiers applied to this button. And this one has another element, the circular progress indicator here. And this one has another element, the text here. Okay? So what I'm doing here is I am conditionally emitting the UI. You guys can see this? Okay, like this you can for sure. Yeah, okay, cool. So I have divided my form in two elements, two main elements. The outermost, which is the login form, which actually is stateful, it has presentation state, and the innermost, which is stateless. I have not used the approach of having a state machine, but this has drawbacks. For one part, it simplifies, right? Because we have an if and an if. It is simple enough, right? But on the other hand, it does not scale well. That is the issue, okay? We could go about and design our UIs like so, but most of the time, we will, if we are not careful, this will grow and grow and will grow beyond our understanding. And that is the problem, okay? Scaling the solution and keep it under control in our mind, okay? That is the issue. But, okay, guys, if we have actually a small screen, there's no point in over-engineering it, except that I am trying to train you in using the state machine pattern, okay, in this solution. But here, I haven't used it to illustrate the idea. But this has issues, okay? This approach has issues, but we will get into it later. As you can see, I've simplified the form, but for other reasons, not only for this class. I have to simplify in the context where this will appear, okay? So, I was saying, here we have the data which I use to generate the composition, okay? Whether it's loading or not, whether there's an error, the email entered thus far, and the password entered thus far. And also, is data valid? A Boolean value indicating whether the current data is actually valid or not. These elements are used for what? Well, to generate the composition. Here, the email. Here, the current password. Here, whether I show or not the error message. Here, whether the button is enabled or not. And here, whether we display or not the circular indicator, progress indicator. Okay? Question. Is it possible to have invalid states here or not? Let me ask you in a different way. What happens if we have both loading and error? It's possible, right? But it shouldn't. You understand? It's possible. But it shouldn't, because it's impossible to have both, right? This means that our design is not flawless. It's okay, it's not a big deal if we have automated tests, but the point here is, my point is, look, I'm not excluding the possibility of having a Boolean value true here and a non-null string. Therefore, it's possible. But it does not make sense in our solution, right? It doesn't. Okay? Yeah? You were, Bernard, yeah? You were going to, no? Yeah. The error is an outcome of trying to do the login. And if it's an outcome, it's not ongoing. It's an outcome. Yeah? So keep this in mind. I know I simplified this, but something was lost in the process. This is okay for simplistic stuff like this, which I immediately see the problem. This is not okay in more complex screens. And that is the argument. This is why I'm spending some time looking at this simple solution, okay? Simple problem. Yeah? For sure. What you are saying is, look, wait, but these are two different problems. One is to whether we have only one view for all the states, or we have multiple views, one for each state. And another is the data I use to represent the possible state. Yeah, for sure. We can have an hybrid approach, meaning that instead of using this, I use a closed hierarchy, for example, a sum type, to represent the possible values of the data. And by using that approach, excluding the invalid states, for sure. And regardless, have all of this in the same view. Yeah, yeah. So yeah, there are two elements at stake here. One, to divide divide to conquer through identifying the state machine and assign to each state a different view. To implement the data types that actually support each of independent states of that state machine. Yeah. So you can have only a part of it and still have some protection against invalid states. Yeah. Okay? We can continue? Let's go then. So this is, here I only wanted to illustrate this, everything I have been saying, and to show you this. On email change, on password change, on login. These two events are pertaining to changes in the presentation state. This is pertaining to the intention of the user to do the login, do the doing. Okay? Actually do it. At the next level, we have this. Easy enough, right? But it does not propagate events for the user interface, okay? Meaning for changing the presentation state. So the presentation state is owned by this form, like so. Oops, sorry. Yeah? This is what I mean with this cylinder, okay? This is the presentation state hosted at the login form, okay? What escapes, what goes out from login form, what is not pertaining to the presentation state, namely application, will become eventually application state, okay? And this is what we have here on login, okay? Another thing is, look, I don't have domain logic in the UI. You see here, this is a function which is received that tells whether the data is valid, acceptable, or not. In what way? Look, I'm not ensuring that the password is the correct one. Of course, that requires communication with the backend. I'm only validating on the side of the client. So when we are talking about domain logic, we are talking on domain logic that can be in both places, in the backend and in the front end, regardless of being a React application or an Android application, and part of it which is exclusively on the server. For example, validating user credentials. For sure, it's not on the client. It must be on the server. Okay? So, validate credentials here is about seeing whether they are acceptable or not. Is this a possible email? Does it have the shape of an email? Is this an acceptable password? For example, does it have not blank characters? Or if it's only blank characters, it's not an acceptable password, okay? So this is the idea of not having domain logic in the UI, okay? And finally, this is the moment where the data presentation state is promoted to application state on click, okay? I call on login, I pass in the user credentials, and those user credentials are possible, acceptable data. And this leads to communicating with. At the top, we have this, the login screen, okay? For now, please ignore this. I will talk to you guys about this launched effect later on. I will also see poor uses of launched effect, okay? I will talk of it in a moment. But what we have here is the login screen, which has a view model. The view model is responsible for interacting with the remaining of the system. On back navigation intent, it's the activity which is responsible to navigate to other activities, other screens. And finally, the modifiers that are required. And this is it, a scaffold with a box and a login form, and this is what we have seen later on the application execution, okay? Again, I have here the validate credentials. It's a is valid credential data. It's a function, a domain function, which I pass on to the login form. And here we have view model login. And here we have observed state here, okay? So if we look at the view model, we see we have a state machine at the view model. We have actually a state machine, idle, login in progress, login success, and login error. This is the host. This is the current state. And this is the login action. If the current state is not what I expect, nothing happens. If it is what I expect, then login becomes login in progress with the credentials I have received here. This means that I will then launch a coroutine which will try to log in here. Okay? Once this either succeeds or fails, the result will be placed here. And because this is a mutable state of, it will trigger a composition and the UI will be updated accordingly. Yeah? We're good? Cool. One final point which I think it's very important, and then I will try to show you guys how flows will enter this equation, okay? So my final point here is this. There are two important rules in Compose. Well, there are more, but these two are, in my view, the most important ones. And the first one is there will be no side effects. What is a side effect? It's something that changes the overall state of the system. But you say, but I need side effects. Yeah, if you actually need side effects, you must put them inside its adequate primitive, which is launched effect. Okay? So keep this in mind. It is forbidden to have something here like service, whatever. Service do some side effect. This is forbidden. Okay? Why is that? It's not like the others. É proibido, mas pode-se fazer. Não é. It is forbidden. What are the consequences of doing forbidden stuff? By the way, what happens if we do forbidden stuff? We go to jail. Yeah? Is it? I don't think so. Not here. Look, I did it. There's no programming model police coming through that door. What are the consequences of doing forbidden stuff? Are you aware of it? Yeah. We get unspecified behavior. And unspecified behavior is a concern. Why is that? Because we are calmly in our place, taking a nap, sleeping over because we are tired, in a hard gaming session, and the phone rings saying we have a problem, Houston. Okay? We have a problem. So we must abide by the rules of the programming model. And the programming model states, I will try to explain why this is a problem. Because actually, imagine that we pose you this question. How many times does this execute? You understand my question? How many executions will ever happen on this code? How many executions happen? Do you have any idea? Let me show you some more stuff. This is the life cycle of a composable. The composable enters the composition. This is what's written here. Enters the composition, meaning it's being considered to display on the screen. And it exits the composition whenever it's no longer required for displaying to be displayed on the screen. And then there's 0 or more recompositions, whenever the data it's using is changed or not. Imagine that we do not have any recomposition. My question is, with no recompositions, how many executions of that code exists? You got the answer, the question? You understood it? No, we do not know. At least one. That is the issue here. We have no way of saying that it will only be one time. It can be more than one time. And this is the point. We cannot, and why is that relevant? Well, if we have effects, the number of executions of the effect is relevant. This is why we cannot have any effects. Okay? But what about what changes here? Well, what changes is that this is controlled by the system. It is aware that this is an effect. And it will only execute it if the conditions required for its execution change. Okay? There's obviously an issue here, which is, well, this is executed within a coroutine. Okay? But we will not use this to call the services. Okay? Why is that? Because this is committed to the composition. And remember what happens when we have a reconfiguration? What happens? The composition is dropped and it's recreated. Therefore, this would be cancelled, but we don't want to cancel it. We want to make sure it continues along during the reconfiguration. So it's not to be discarded. Okay? So, yeah. Yeah, no. This block is executed in a coroutine, yeah. Because we don't need it. We don't have any suspending. Look, there's a direct dependency between if we have a suspending point, we need to be executing this in a coroutine. There's no implication in the other direction. So it's not because we have a coroutine that we must have suspending points. Okay? Yeah? You are thinking still. Yeah.
To create the lobby, and I decided this. I wanted to when to click on the creation of the lobby. I want to go straight for
You want to navigate away, right?
to the lobby screen of the lobby.
Prior to succeeding or after? You understand the question? So this is an important point. You cannot navigate while something is happening after the, yeah.
Because
This is exactly the same approach here, I understand. This is this.
if the success happens,
Then you will navigate too. Yeah, seems right. Yeah. How is it used? I'm using this. I'm not using the result for anything. I am producing an effect, a side effect. I will not consider. No, look. This coroutine executes in the same dispatcher that this executes. Where does this execute? In the main UI thread. Because these are callbacks, event handlers. They can have side effects. But this here, this part here, line 45, is inside the composition. And the composition cannot have side effects. It's different, okay? One thing is the handlers. Another is the code that specifies the composition. The event handlers are executed in the main UI, the main thread, the UI thread, or the main dispatcher. Every coroutine executed there executes in the main thread, meaning that those coroutines cannot block. They can suspend. They cannot have blocking code. Okay? Yeah? But this is a different thing. This is about ensuring that we execute a side effect while the framework is aware of it, that this is a side effect. Because the framework expects side effects to happen inside event handlers. It does not expect events to happen inside the specification of the composition. This is the use effect of React. Are you guys already studying React? Not yet. You will. Okay? You will. Some of you at least. Okay? This is the use effect of React. Same thing. Okay? Except in this case, we are using Kotlin's concurrency model, therefore using suspending functions and coroutines and whatnot. Yeah? Okay? You got it? So here, I'm not collecting the result. No, I'm just saying, look, if this changes, cancel what's inside here and launch it again. If it hasn't changed, don't launch. You just launch it once. This is what I'm saying in this construction. This construct here, okay? In this case, I don't need any suspension point. So I wouldn't need this to be executed inside a coroutine. But that is not the general requirement. The general requirement is I will have to have suspension points here, and therefore I need it to be inside a coroutine. You would ask me, what kind of suspension points, Paulo? Because you just told me that we shouldn't have I/O here. Yeah, but if we have animations are by definition comprised of timings, right? Yeah, so we will have suspension points in animations. Yeah? Okay? Great. So keep this in mind. Here, I'm just saying, okay, cool, login succeeded. Let's navigate somewhere else. Yeah? And this will make the composition irrelevant. It will be taken down and, well, we will be in another screen. Okay, guys? Well, I hope this has helped you guys figuring out what goes where and what kind of rules are we subjected to, okay? Another important thing that I may not emphasize enough, because most of you guys are already familiar with the need to use, or with the merits of using immutable data, but there's another element important here, which is this. Everything I put here inside instances of mutable states are immutable data. Okay, let me collect this here. I have also a... Okay, don't mind everything else, just mind this, okay? Oh, some of you guys also asked me, why is this by there? What's the difference between the by and the equal sign? So here it is. If we would use this, remember mutable state of, then we would have in email this. This is the instance of mutable state of. When I say that we have mutations, we don't have mutations of the graph stored here. We have mutation, the only mutation happening here is the one that changes the currently observed state. Okay, this value here. The object itself, it does not change. This is important. Don't go about changing the field or a property of this here and expect this to behave correctly. It will not. Okay? It will surprise you or not. It will not behave correctly. And the by is simply to prevent to have to always write email.value, email.value, email.value. Okay? Hence the by, it's delegation. Cool. So finally, I think we have everything we need. Let's look again with some to the go. So this is this is the demo of the login I have provided, headed to this. Let's look again at for a brief moment, at the login service. No, not login service. Joke service and joke of the screen and joke of the whatever. Yeah, cool. So again, the joke service. So the joke service is, for now, this: suspend, get joke. What is the main, is this? So my purpose is to have access to jokes, to the set of jokes, in the same way that you guys need to have access to the next move or whatever, okay? You need to communicate with the backend server, be it through a web API, be it through Firebase, Firestore, okay? We can think of it as the same. Let me just, okay, it's cool. So I was saying, yeah, so is this contract correct? You understand the question? Is this right or wrong? Correct or not? And why? Does it seem right? It is right. It is correct, meaning that this is not flawed. It's not wrong. Okay? Is it ideal? That's another conversation, but it's not flawed. Whether should this be like so, then I would state, yeah, it's flawed, because this involves I/O, and I/O should be called within a suspending function, should be performed within a suspending function. Okay, obviously non-blocking I/O. Cool, great. So here we have our get joke, but this is actually, in a perspective of software design, it's not ideal. Why is that? Because this is a pool contract, meaning it enforces a pool communication model, right? We have to ask it for the joke. Give me the joke, please. If I want to have a systematic request of give me a joke, I will have to keep asking it, okay? So this is what we have now. Let's execute it here, and let's look at it here, jokes demo. And here it is, right? It's getting the next joke. It will stay showing it for a while, then it will start fetching another joke. I'm not sure for how long. Yeah, here we go. Another joke. Get me another joke. Okay. We could keep displaying the current one while, but yeah. This is a pool model. What is the problem? Or is there a problem? You are going to build a distributed application. For all purposes, it is a distributed application, a turn-based one. You are going to play with other users. If we should use this approach, what is the good period to ask for whether the other player has played or not? You understand? Here I am, each 10 seconds, asking for another joke. It's for demo purposes. Let's imagine that we are going to put this in production, your game in production. How long should pass between several requests of, has the other player played? We cannot know, right? There's no way of knowing. So there's not an adequate solution for this problem. What do you say whenever someone is very interested in something you have or you will do? What do you say to them? when she starts to asking a lot. You say, look, read, I will tell you when it's done, right? You will invert the communication model, revert it, by stating, instead of using a pull model, I will use a push model. I will tell you that it's done, right? So this is the ideal approach. So, but this requires participation of the server. For you guys that are using Firestore, don't sweat it. Firestore has it, a push communication model. It comes naturally. But what about you guys that are building a web API? You will not have it out of the box. You will have to build it. Yeah. Okay? And that's not a big deal. It's not rocket science. It's easy enough. But the point is that regardless, we want to have it here in our client. Okay? So I'm aware that I cannot do this today, but I want to show you guys how this will go for being, how will this become going forward. Okay? So you can prepare your solutions for this. This is next week's lecture is about flows. Okay? So instead of building this like this, what if we would say, I would like joke service to push new jokes. How will we design it? Okay, you understand? How? Well, joke service pushes jokes like this. And here, there you have it. Flow is by definition a primitive for push model communication. This states that the joke service pushes jokes. Joke is a flow of joke, meaning that they will flow through here. The client will collect that flow and do whatever. How are jokes injected, placed in that flow? Well, using a flow builder. Simple enough, right? Yeah. I will show you guys. Don't sweat it. Okay? But the point is, instead of having a pull API, we have a push API. Some of you guys could see, look, wait, but there's a huge difference here. I may want to state, look, the flow starts now. Cool, then we can do a hybrid like this. I like Get Your Scream. And this is a hybrid. Not a great name. Get Joke. Get Jokes, yeah. And here we have it. This is a hybrid solution. The flow is returned by the function I call. Notice that this does not require the function to be suspended. Okay? This is our topic of the next lecture Monday. Okay? But I want to highlight that this means that here on the view model, instead of having a mutable state of, which is specific to compose, we will have another primitive for the push communication model, which is var cur state. I will call it cur state, not var, val state, which is a flow of joke of strings. Oops, sorry guys. Okay? And how, can you see it? Okay, let me just. And how will we collect it? How will we get it on the other, on the UI? Easy enough. Joke of the screen instead of using this, we use, I can, yeah, while cook state okay, and here you go. This is the default value, okay? Whatever, idle. Joke, screen idle. And this is not dot value. Okay? We will have something like this. And the rest, the remaining, stays the same. Okay? So, if you guys are already using this idea of the state machine, probably you will have no problem going forward. Okay? So it's imperative that you guys change the solution towards this. Why is that? Because a difficult, a non-trivial screen is coming. The game screen. Okay? It's not trivial. It takes work and it's big. Okay? Okay, guys? And that's it for today. So next week, this week, I will be trying to help you guys fixing this so it becomes this, okay? And next week we will talk about flows, okay? See you next week. Como é que é, Manso? Estás bem? Já acabei o Elisés. Não faz mal, não te preocupes, já acabei a aula agora. Já acabei, já. Tudo bom, meu? Vou para outra. Para a outra já, caramba. Poxa, vocês levam uma dose. Força? Yeah.
I noticed, Mr. Anderson.
Yeah.
Before you said that the grading is different.
Yes. You have to do the project, the assignment.
Mhm.
Okay. You have a group, a work group. Okay. There are three options. You can look at them in the GitHub or I think that in you have classes on Thursday and or Friday. Besides this one, Friday, come on Friday to talk to me. Okay, I will have a class now, so I must hurry. But we will talk. But first, you need to find a work group, someone to work with. Otherwise, it would be difficult to work alone. There are other Erasmus students, so try to see whether you can work with them. Some of them are working already with guys from here, so you should come to see whether they are there or not. But you don't know anyone, but it's okay. But if not, you may work alone. It's not a problem. But you should come every Friday. Okay, so you can work and have my support there. Okay. Okay. See you next Friday then.
Só foi definido o current state no ViewModel.
Yeah.
E que nós temos como um private set, estamos a fazer um mutable state flow do ViewModel, acho eu.
Portanto, estás-me a perguntar, deixa-me ver se eu percebo.
O current state, como é que tem definido no ViewModel?
No ViewModel, ok. So, vamos aqui ver.
É porque neste momento, se nós quiséssemos só colocar
Aqui, estamos a falar disto, não é?
Current state.
Vamos falar disto?
Exato.
nós não temos como.
Calma, aqui isto é um defeito, mas eu também não me preocupei muito com isso porque isto vai desaparecer. Que é, eu estou a deixar passar estado mutável para fora do ViewModel, isto não é ideal. Portanto, idealmente isto deveria ser uma coisa deste género, private set.
Sim, é como é
Yeah.
nós temos, mas como se calhar já temos isso com private set, já não conseguimos.
Nós temos isto, pois exato, nós temos isto desde baixo, mas isto a fazer de cima.
Não, que eu vou mandar fora isto, isto não me interessa, não gastem muita energia nisso, percebe? É provável que tenham visto disto nas minhas outras demos de outros semestres também, mas percebem a preocupação, é para evitar que o estado mutável esteja
Sim.
no exterior. No exterior só lê, escrever é vindo de dentro, esse é o argumento. Epá, mas eu aqui quero fugir disto à zap e, portanto, nem sequer falei disso. Ok? Para dar o salto para a frente e vamos fazer para aqui.
Está bem, está bem.
Está bem?
De resto, está.
Tá? Perceberam, não é? Pronto, a ideia a ideia aqui era mesmo a malta conseguir arrumar.
Não, é que nós tivemos noutra aula,
Certo.
aquela aula para mostrar como é que está o
Sim,
software.
sim, sim, sim,
Mas
sim.
nós temos tudo como
Pronto.
basicamente.
Ok.
que é- pronto,
Pronto, a ideia é garantir que a malta, ou garantir não se consegue garantir, mas é pelo menos tentar ajudar no sentido em que continuam a conseguir, conseguem continuar a avançar, porque a complexidade dos ecrãs vai aumentando.
Sim, sim, sim.
Uma coisa são estas demositas da treta que eu faço, outra coisa são aplicações a sério, relativamente realistas, epá, e que ficam com uma complexidade em termos de volume assinalável. Pá.
Pois, temos assim, aqui este. Temos com o Private Set.
Sim, com o Private Set, que é o que, é o que eu estava a dizer. É o que eu costumava fazer quando andava. Porque o que é que acontecia antigamente? Antigamente a malta da Lake não tinha flows. Ok? E portanto nunca tinha ouvido falar. O que é que eu preciso? Pá, eu só podia falar de flows lá mais para o fim. Então arranjava aqui uma solução de compromisso. Só que agora a malta, eu já fui, estive em PC, estive a falar com os professores de PC e chegámos a. Ok, falámos sobre flows.
Os launch side effects eu já tenho feito com o Immutable State Flow, para dar limite do estado.
Sim.
Sim.
Sim, 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 sim.
E,
Sim.
pronto.
Sim.
Então, pronto.
Sim.
Depois
Isso é o que eu vou
disso,
falar na próxima sessão.
ok.
E depois então já podemos ir brincar à seriação, deseriação, pedidos
Nós vamos
HTTP.
fazer o jogo, nós já temos.
Já estão de volta. Sim, é o que se espera, que agora a malta esteja de volta do jogo. Yeah.
Porque nós já temos o quê? Já temos já uma semana feita.
Sim, aquilo dá trabalho, aquela parte dá trabalho. Só tem 2 semanas, do ponto de vista da matéria, do conhecimento da infraestrutura que é preciso ter, é muito pouco, porque aquilo é domínio, sobretudo. Mas dá trabalho. Ok? Portanto, se já começaram, perfeito.
A cena é. Nós somos de LEP, então ainda
Eu
precisamos.
sei, eu sei.
Então,
Sim, é muita coisa, fazem bem.
nós temos que
Sim.
ir adiantando coisas.
Yeah. Sim, fazem bem.
Mas pronto.
Vá, malta, fiquem bem, vá. Até quinta ou sexta, vocês. Até quinta, vá. Ok, então já vou continuar a próxima aula, vou parar aqui a stream um bocadinho. Ok, parar isto. OBS, onde é que estás, OBS?